On this 2010 to 2015 Honda Civic with the 1.8 gas engine, P1298 points to an ELD circuit high-voltage fault. In plain terms, the PCM is seeing an electrical load detector signal that does not make sense for the circuit. The car may have a check engine light, and it can have charging or electrical load monitoring behavior that seems abnormal, though the engine may often still run normally. The possible fault areas are the ELD itself, its ignition feed, its ground, the signal wire back to the PCM, or in some cases PCM software or the PCM after the circuit checks are proven out. Before getting into pinpoint checks, start with the basic system checks and follow a structured diagnostic approach. Start by duplicating the fault. Turn the ignition switch to on Roman 2 or use the engine start/stop button to select on mode. With the HDS, look at ELD electric load value in the data list. If it shows 0, 2 or less, the fault is duplicated and you move into circuit testing. If it does not show 0, 2 or less, treat it as intermittent for now. The system is okay at this moment, so check for poor connections or loose terminals at the ELD and the PCM. If captured operating data is available for this code, try to reproduce the fault under those same conditions. Next, check the IG1 ACG feed. Turn the ignition switch to lock 0 or select OFF mode and disconnect the ELD3P connector. Then turn the ignition back to on Roman 2 or select on mode. Measure voltage from ELD3P connector terminal No. 3, the YEL wire to body ground. You are looking for battery voltage. If battery voltage is there, the IG1 ACG feed is okay and you continue. If battery voltage is not there, check the No. P1298 fuse in the under- fuse and relay box. If that fuse is okay, repair the open in the IG1 ACG wire between the No. P1298 fuse and the ELD. Now check the ELD signal wire for an open. Turn the ignition switch to lock 0 or select OFF mode. Jump the SCS line with the HDS, then disconnect PCM connector A, the 51P connector. With the ELD3P connector still disconnected, check continuity between PCM connector, a terminal No. 34, the ORN wire, and ELD3P connector terminal No. 1, also the ORN wire. If you have continuity, the ELD signal wire is okay, and you keep going. If you do not have continuity, repair the open in the ELD wire between PCM A34 and the ELD. Next, check the ground side. With the ignition still in lock 0 or OFF mode, the ELD3P connector disconnected, and PCM connector disconnected, check continuity between ELD3P connector terminal No. 2, the BLK wire and body ground. If continuity is present, the ground wire is okay, and you move to the ELD substitution check. If continuity is not present, repair the open in the ground wire between the ELD and G301. After the feed, signal, and ground checks pass, substitute a known good ELD. Turn the ignition switch to on Roman 2 or select on mode. Reset the PCM with the HDS, perform the PCM idle learn procedure, and then check for pending or confirmed DTCs with the HDS. If P1298 is still indicated, update the PCM if it does not have the latest software, or substitute a known good PCM. If P1298 goes away after the PCM update, troubleshooting is complete. If it goes away with the known good PCM substituted, replace the original PCM. If P1298 is not indicated after installing the known good ELD, replace the original ELD. The key with P1298 is not to condemn the ELD until the ignition feed, signal circuit, and ground path have been proven. Verify the code, work the circuit in order, then confirm the repair and make sure P1298 stays gone. For more diagnostic training, visit stepdiagnostics.com.